Alright, hello everyone, and here we go to another tip for my YouTube channel. My name is Fabiano Amorim. I'm based in Brazil and I'm a data platform MVP, and I'm currently working in a company called PCN Group as a database consultant. Anyway, let's go ahead and I want to keep this video short, and I have a lot of things to show. And this is new, and may change a lot, but as far we can tell now, this feature sounds really interesting. It's the adaptive query processing. The idea is to change the default behavior, how SQL Server is running queries today, and as the name says, adapt the query, maybe the query execution or the memory grant, to have a better plan and a better execution plan. And I would like to show today two things. One, it's already working, and the other one, which is the batch mode execution adapted join, isn't working yet in the current CTP we have, but we should have more details and more we'll probably be able to test it soon. So the batch mode, the main idea is just if you have a query that is misestimating or exceeding estimations for memory grant, query execution can adapt and get a better estimation and a better memory grant based on the actual values that is reading. For instance, if your query is, if you have a query plan that is estimating you need 10 megabytes to sort something, and you in fact only need 2 megabytes, then you're pretty much wasting 8 megabytes. And what the feature does, it can detect those kind of things and adjust the memory grant in real time. In the batch mode adaptive join, it's the adapt the join that a SQL query optimizer choose to run your query. So depending on how many rows you are reading, a hash join or a loop join might be good. For many rows, probably hash join is a good option, but for just a few rows, a loop join may be good. And then again, query optimizer, when creating the build phase in the hash join, it can decide if you're just let's suppose query optimizer estimating to read like 1,000 rows from a build phase from the build side in the hash join, and in fact it is not reading 1,000 rows, it just read like 20 rows. Because it was estimating to read a lot of rows, it chose initially to run the join using the hash join, but then now that it knows it just read only 10 rows, it can kind of switch automatically to the loop join, and then use a loop join as a join. Let me show you, and before I show you, just two links, and the second one is where you can sign up for the query processing preview, so you have more information about this, and if you want to join the team and test those features in your live environment, Microsoft can help you in setting up everything. Let's go to the demos, and I think you understand it better. So now how it works now. Let me zoom it a little bit. So I have this Northwind database here, and I'm going to create a table called products big, and it's already in cache. And here's the query I have. It's just select star something where product ID between 1 and 756. Let's run this query and let's see the actual execution plan. Let's go. Where are you? Include actual execution plan. Okay, so here's the actual execution plan. The query is fine, and the sort looks fine. And here I'm running this on SQL Server 2016 Service Pack 1. Okay, and so far so good. And now, instead of reading up to 756 rows, I'm going to read just one more row. Okay, and that's the problem with the sorts and with spilling data to TempDB. Because I'm reading just one more row, the memory it had initially to process this sort operation in memory wasn't enough, and then instead of just spilling one row to TempDB, it's not how it works. It spills everything to TempDB. Here we can see we wrote a lot of pages to TempDB. Okay, because the initial memory grant wasn't enough, which was around 6 megabytes. Okay, so that's how it works today, and there are a lot of alternatives to fix this, and this is not what I want to cover today, but just one of the alternatives. You can kind of fake or mimic that you're going to read more data that you're actually reading, and then SQL Server is going to estimate it needs more memory, and then you will not have the spill to TempDB. Now instead of having a grant of 6 megabytes, it got 8, and 8 was enough to process just one more row. Anyway, that's what we usually do, and there are the trace flags and hints and a lot of other options to fix those kind of things. But there's a new thing on 2016, which is the sort operation running on batch mode. So if you remember, batch mode was introduced with the colon star index. And let's come back here to the query. If you don't remember, a query execution, it's pretty much row mode for everything by default since 2000. And it changed with colon star. And what changed? Well, by row mode, I mean it's reading one row and then asking for another row and another row and another row. With batch mode, instead of reading row by row, SQL Server is reading several rows and then using batch rows. So it's in very short that this is the difference. Instead of reading row by row, it's reading a lot of rows and sending all of them at the same time, which is very nice. And the problem with the batch mode, it's that this is only enabled with colon star indexes. But the good news is that on 2016 we can have a non-clustered colon star index in a table with a clustered index, which is my primary key here, and you can have a filtered non-clustered colon star index. And this is what I'm doing, and I saw this in a Itzik Ben-Gan article. He's pretty much creating a dummy index here that doesn't do anything because I clearly have a contradiction here, and the idea is just to have a colon star index in the table, and this is all Cryptomizer needs to evaluate batch mode in the operations. Alright, so I'm just creating a stupid index here just to have a colon star index in the table. And now I'm going to run the same query. It's a bit different because I'm saving these two variables just because I don't want the result set here. I know I could right click and go to the query options and then use like discard results, but I will use this in the query stress. So I'm saving two variables just to save my save some work here. So let's run this again. And now, since I have the clustered column star, the non-clustered column star index, the sort, I'm expecting to have sort running in batch mode. So the first thing we can see here is I'm not using any trick like convert something or trace flags, anything like that. I'm running the same query. The only difference that now I have the column star index, and as you can see here, the batch, the mode now, the execution mode is now batch mode instead of row. Okay, and now is not going to TempDB because now SQL Server got a lot of memory. Well, this is good. So batch mode works really good, and it's definitely better than row mode. Of course, depending on your data, etc. But in general, it's much better. The performance is just amazing. But now, as you can see, I got a lot of memory to process this. So almost 187 megabytes to process this. And now I have a warning here saying, hey, you probably got too much memory, and that might be a problem for you. For instance, how many queries I can run in parallel? Let's suppose I have an application and is calling this at the same time with several users at the same time. So how many of them I could run? So let's try to simulate this. And I'm going to open the query stress. And let me grab this query and paste here and go to the databases. Connecting to my 2016 instance. Let's see if it's working. Okay, it's running. And now let's try to run 100 queries and with 10 sessions. And go. So they are running. And let's see what is running here. 2016. Okay, already finished. Let me run again. Where are you guys? What happened? Let me think. Okay, let me put 200 here. Go. Where are my queries? This is weird. 10 threads. Okay, let's try it. More threads. Okay. Anyway, not sure what happened, but now query stress is really working. And now, as you can see, I have only 3 queries running. All of the other queries are waiting, and they are waiting for memory. All right, the resource semaphore wait we saw there. This is looks like the who is active is not working. Let's try to DM OS waiting tasks. Let's see here. Yeah, looks like there's some bug with query stress. Anyway. Anyway, they are running. Let me cancel this. But you saw that I had only 3 queries running, and the other queries were waiting. Why they were waiting? Because I didn't have enough memory to run more queries. And this is because I estimated that I needed a lot of memory. That might happen in your environment. And here is the fun thing. Let's try the same thing, but now on vNext. Let's see. So I have the CTP 1.4 here installed, and let's create the same table and the same non-clustered column start index, and now I'm going to run exactly the same query, and both instances are configured to max server memory to only 1 gig, so only 1 gig available. And let's run the query. So the first execution, let's see the actual execution plan. So as you can see, I'm running the free-proc cache to clean up the cache plan. And okay, I should expect the same thing on the vnext, so the same amount of memory and the same warning saying excessive grant. But now the fun thing is the adaptive query understand that this is estimating for more than it actually needs, and then when you call the same query again, it automatically adjusts the memory grant for your query for the value that it really needs. This is just awesome. I will run the same query again, guys, but without cleaning the cache, and check what happened. No warnings. Why? Because if we look now, the memory grant it got, it's only 3 megabytes. And now how many queries I can run? Well, let's try to change this and use vnext ct next 1 and 4. Okay, it's working, and go, and I hope whoisActive works. Let's see. Let's see if I'm going to capture something here. Okay, this is definitely weird. Let me cancel this and try again. Okay, let me kill SQL Crew Stress. If you ever use SQL Crew Stress, you know it doesn't work pretty good sometimes. It's an awesome tool, but there are some weird bugs. Feed next 1 4. Okay, let's try 100 threads and 100 execution. Go. Okay, I'm not sure what's happening. Alright, anyway, now it's running, but as you can see, now I have much more than only 3 queries running, right? So that's what I was expecting. So I didn't anything. I haven't changed anything. I didn't change the query. It just automatically adapted and adjusted the memory grant. So this is just awesome, guys. And there are some extended events called excessive non-grant used, and there are other events. Let me show you here. The sort memory grant adjustment and memory grant update by feedback. So that's the feature that we are talking right now, the feedback, and that update the memory grant. So this is just awesome. So search for the extended events and you find more information about it. Alright, this is one feature, and the next one, let me show you real quick, is the adaptive join execution. And the adaptive join execution, I'm going to create the same table. Oh, actually I'm going to create now 2 tables, order and customer. They're both big, order big and customer big, and they have 1,000,000 rows in it. And then I will create 2 dummy clustered or non-clustered column star indexes just to use the batch mode. And notice those 2 features I'm showing right now, they only work with batch mode operations for now. Microsoft is definitely going to implement them in row mode as well, but they are working now with batch mode. They work first on batch mode. And here's what I'm talking. So let's suppose I want to join orders with customers, and let's see what is the execution plan that SQL Server choose to run this. Include actual. Where are you? Actual execution plan. Okay, it chose to run the query to join those tables using the hash mat, and the hash, as you can see, it's running in a batch mode, which is very good. And alright, so what I have now here, it's instead of reading A2507 rows, now I'm going to kind of fool query optimizer, and I'm going to run the query. It still thinks it is going to read A2507 rows, but it's going to read only 100 rows. And of course, the execution plan is going to be the same. But the question now is, wasn't it better to read to join those tables using a loop join? For instance, if I force a loop join, let me show you the performance difference, and I have profile here, and I'm going to run both queries, and as you can see, the first query, it's taking much longer than the query that it's using the loop join. So the idea here is that second execution, or any of the executions, are going to automatically adapt and use hash or loop according to how many rows it read from the either loop join or the build hash join. So what I'm saying is, if it's the hash was chosen, but if the hash build table only reads rows that a loop join would make more sense, then Query Optimizer will choose the loop join here, even that initially it chose for the hash mat. So I added some tests here explaining a little bit further what I just said. So if execution starts by scanning the build side of the hash join to create the build and the buckets and etc. But if the number of rows in the build side it's less than the threshold at which the optimizer would have chosen for the loop join, then the hash join is aborted and the build side becomes the other side of the loop join. This is pretty awesome. So I'm still trying and working with this. I'm not sure if it's already working on CTP 1.4, and it looks like it isn't, but I couldn't make it work at least, but that's the idea on how this is going to work. Alright guys, this is it. I hope you like it, and see you soon.